is the start of our lesson, and the first thing we are going to learn about this evening is mutually exclusive events. Okay, so tonight we're going to talk all about the laws of probability and the different types of events that you can get. So let's kick off with just some simple ideas with cards. So let's think about it. When you play cards and you've got the red and the black, those are your two colors, and you've got diamonds and spades and clubs and hearts. Those are your four options for the little symbols on the cards. So can a card be red and black at the same time? Just pop your answer in the chat. Can it be red and black at the same time? No, it can't. Yeah. Everyone's a bit suspicious of my question, Miss Coco. It's too easy. Everyone's like, what is she up to? Is this a trick question? Okay, so next, can it be black and a 10 at the same time? Yes, that can happen. That can happen. You can have a 10 of clubs or a 10 of spades, yeah. And then can it be a king and a queen at the same time? No. Nice answer, Bomb. Love it. Love it. Okay. So those examples, A and C, those we call mutually exclusive events. And they are basically events that cannot happen at the same time. So for instance, you cannot be at home and at school at the same time. Those are also mutually exclusive. And you cannot play soccer and rugby at the same time. Well, some people do, but you can still not at the specific time homeschool, be at school and at home at the same time. Shiraz, you're being too clever. It does mean that if you actually go to school, you can't do both. Okay, give me some examples in the chat from your own life of events that are mutually exclusive. Come on, Tobians, some examples. I've given you a few. We've done a few with the cards. Think of your own example and pop it in the chat. Sleep and awake. There we go. Drawing and watching TV. I think you can do those at the same time.
I mean, you won't concentrate very much on one of them. But
you can't go to the mall, sports practice at the same time. Driving a car and cooking, that would be a bad idea, Claw.
I mean, you could do it, but don't. Please don't.
No, yeah. It's not recommended.
No.
You can't clean and study at the same time. Yeah, it's literally things that you can't do at the same time. Okay. So you guys get the idea, right? It's all about driving and walking, washing dishes and doing homework. Yeah, you just literally, we deal with mutually exclusive events on a daily basis because we literally can't do the same thing at once. We can't be running and driving, sleeping and cooking, homework and washing dishes. All of those examples you guys have named. Okay. So in terms of our probability rules, what we then say is the probability of A and B, with A and B being two different events, the probability of those two happening and having an overlap. Remember when we said in our previous lessons about and has to do with intersection. So if we have A and B like that, then there is overlap. So with a mutually exclusive event, you cannot have that overlap. So the probability of A and B equals 0. There is 0 chance of you running and driving at the same time. There is 0 probability of you doing, what else have you guys mentioned? Showering and wearing clothes. There's 0 probability of studying and watching TV, doing things together at the same time. Okay, so that's the first thing with mutually exclusive events. But when we look at the probability of A or B, so if I look at event A as a Venn diagram, and event B, then the probability of A or B, remember we said with or we include everything. We take A and B all together. That is the probability of A plus the probability of B. And on a Venn diagram, here's a little picture. There's no intersection when you are doing mutually exclusive events. Okay. Give me a thumbs up in the chat if you are on the same page and if you're understanding what we have said so far about mutually exclusive events. Nice. How many are we in the chat? 78. Okay, right. Oh, there's Sanat, he's gone. Okay, so let's keep this in mind with the mutually exclusive and the probability of A and B being 0, but the probability of A or B, we're still going to add those two probabilities together. Okay, now that's the one thing. Now, the other very important rule that you learn in probability is this addition rule of probability. So you can take it down or take a screenshot of this rule here, because that's basically the main rule that you're going to be using until matric, eh? This you do until matric. So don't think that you can forget it. Siamo, P means probability. That's what the P stands for. Okay. And I'm glad you asked, because I really don't want anyone sitting here wondering what things mean. And then, yeah, you just lost. That's why you come to Watobe. Okay, so the addition rule of probability is that the probability of A or B is the same as the probability of A plus the probability of B minus the probability of A and B. So in simple terms, if I take this event A and I'm putting it in a Venn diagram, and there's this event, whoa, that circle is too skew. Let me undo that. And that is B. Okay, and we've got this intersection here. And you guys remember about the intersection, huh? So that is the probability of A and B. So to get the probability of A or B, we're going to take A plus B, but we have to subtract the overlap. Otherwise, we are double counting. So that's where the rule comes from. If we have the probability of A or B, and we have these two events that intersect, we take A and we add B to it, but we have to subtract the overlap. Otherwise, there's double counting happening. Okay, so let's have a look at this first example, and then it will make a bit more sense. In the Venn diagram, sample space S contains the numbers from 2 to 9. The elements of event P are the multiples of 3 in S. Gosh, we are using all these big words in probability, but I think you all know what these words mean. Sample space is just what we see in that Venn diagram with the rectangle around it. It is everything that is included, which are the numbers 2 to 9. And then event P are the multiples of 3. So just look at the Venn diagram and you'll see there's 3, 6, and 9. And the elements of event R, so that's the circle labeled R, are the multiples of 4. So 4 and 8 are in there. That makes sense, right? Because if it's the numbers 2 to 9, then 3, 6, and 9 are the multiples of 3, and 4 and 8 are the multiples of 4. Okay, got it. So are events P and R mutually exclusive? Pop your answer in the chat if you know. Are the events P and R mutually exclusive? Some say yes, some say no. Some say no, some say yes. They are. Let's Go back. Remember, mutually exclusive events are shown through no intersection. They cannot happen at the same time. So look back at our first slide. There's no intersection, so they are mutually exclusive. So that's a resounding yes. Don't worry about question B. We're going to skip that one because we haven't really talked about disjoint sets. But let's go to question C. Determine N of S, where S is the sample space. So who can remember N of S? What does that mean? Where S is the sample space. Pop your answer in the chat if you know. N of S, where S is the sample space. The number of, nice Tandukazi, that's it. So what is N of S for the sample space? It is not the elements. What you guys are doing is listing the elements. That's it. Thanks, Miss Coco. Miss Coco just gave you guys such a big, well, she gave you the answer. How many elements do we have? That is what N of S stands for. And that is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're going to use our addition rule for the first time. Yes, it is 8, Nelly. That's right. Use the addition rule to determine the probability of P or R. Okay, so back home, I want you to write down our addition rule for this example. The probability of P or R equals the probability of P plus the probability of R minus the probability of P and R. Okay, we are calculating the probability of P or R. And then the probability of P, that is going to be 1, 2, 3. There's 3 elements in P. So that is 3 of the 8. Remember, we always put the probability over the total. And then the probability of R is 1, 2. So that is 2 over 8. And the probability of P and R being mutually exclusive, that means that the probability of P and R is 0. Thanks, Shanaz, that's right, it is 0. So our final answer is 5 over 8. So the probability of P or R is 5 over 8. Okay. Put a thumbs up in the chat if you're happy with that. Using our probability rule, our addition rule, and also doing mutually exclusive. Thumbs up. If you are giving a thumbs down, remember what we say. We always say, ask a question. And if you ask a question, be quite specific so we can zone in on exactly what it is that you need. Okay, right, let's go. We say 0 because there is no intersection. Yes, Yenzi, that's right. Why is it 2 over 8? Okay, it's 2 over 8 because there are 2 elements in R. Here we go, guys. Check on the screen. It's the 1 and the 2. 2 elements in R. So it's 2 of the 8 things are in R. Anything else? 2 over 8, I've answered. Okay, right, good stuff. Let's go on. So that's our mutually exclusive events. Now let's go on to complementary events. Now, complementary events just mean that y minus 0, Ms. Coco, will you answer Tsiamu? Thank you. Okay, so for complementary events, and we've done this already a bit, we have events of which the probabilities must add up. to 0. Okay, so let me just quickly grab this from here. So for complementary events, we have the probability of A plus the probability of not A, that must equal to 0. So let's do this example. And I want everyone to read. And when you're done reading, just post your glasses face. Say this one here, newbies. If we read and we're done reading, we post the glasses in the chat so that I can see when everyone is done reading. Glasses face. Very cute. And there's the monocle. Okay, so now let's draw a Venn diagram. Oh, wait, I'm getting ahead of myself. Venn diagram is question B. So let's first say, out of a group of 27 girls, 10 play netball and the rest do not play netball. So how many do not play netball? Pop it in the chat. 17. Anamika's first. Well done. 17. Because if it's 27 altogether and 10 play netball, then 17 do not play netball. Okay, I'm going to give you a minute to draw your Venn diagram for this event or for this situation. Take a minute to draw it on your own with the numbers and everything, the labels. And if you are quick with your Venn diagram, then you can go right ahead and answer the questions as well. They are they are mutually exclusive, and they are also complementary. We're going to talk a bit more about that now, about the complementary part. Mutually exclusive and complementary. Okay, so minute is up. I hope you're done with your Venn diagram there at home. Oops. That's always a bit disconcerting when everything disappears. Okay, it's back. Okay, just wait with answers, Shiraz. Shiraz is on fire this evening. She's just firing off answers. Yeah. Okay, so netball and do not play netball. I'm just going to label it like that. So those who play netball are 10 and those who do not play netball are 17. So the question is, are the events play netball and do not play netball complementary? Are they complementary? Someone said that they're mutually exclusive, but are they complementary? Muneti says no. Anyone else? Any other ideas? Why are we saying no, guys? And then change it to yes. Okay, I want a volunteer to tell me why they think that these two events, playing netball and not playing netball, are complementary. Amachli says they don't add up to 1. Shiraz still says no. Okay, let's hear from someone who says no. There we go, Boniwe. You can't play netball and not play netball at the same time. They are complementary. That's the first thing. So the two things are not intersecting. The second thing is, very nice, Katlano. You have shown us, you have proven your case by saying that 10 over 27 plus 17 over 27 is 1. And the probabilities of complementary events add up to 1. Okay, so the first thing to check for complementary events are always, is there an intersection? No, there isn't. Do the probabilities add up to 1? Yes, they do. That's how we know that it is complementary. So we are going to say yes. Yes, thanks for clarifying that, Ms. Coco. The probabilities must add up to 1. So the probability of playing netball and the probability of not playing netball must add up to 1. Okay, so NS, where S is the sample set, again, N is the number of elements in the set, so that is 27. And now, it's not always yes for complementary. They must meet both those conditions, okay? The probabilities of the two events must add up to 1 for it to be complementary. Okay, so one of the 27 girls is chosen at random. What is the probability of the chosen girl plays netball? Yes, that's a lovely summary, Shiraz. It adds up to 1 and there's no intersection. Then it is complementary. Well done. The probabilities add up to 1. Okay, so what is the probability of the chosen girl playing netball? Pop it in the chat. A few of you have done that already. Let's see. Always put your probabilities over the total. 10 over 27, that's right. And then a chosen girl not playing netball is 17 over 27. And then we get the probability of playing netball plus the probability of do not play netball equals 10 over 27 plus 17 over 27. And that gives me 1. Therefore, the events are complementary. So you can write it down exactly like that because this is a really good example of complementary events. Yes, Yenzi, that is 1. Okay, right. So those are our important things. Mutually exclusive events, the probabilities. The probability of A and B is 0. The OR rule or the addition rule of probability, which we are now going to practice using lots, and then the complementary rule, which is that the probability of A plus the probability of not A must equal 1. Yes, so if there's intersection, the two probabilities will not add up to 1. Okay. Right, let's see how we are going to use our addition rule in a bit more detail. And some of you who have done probability might have seen these kinds of questions already. So make sure you get a screenshot or you write down the addition rule, the rule for mutually exclusive events, and the rule for complementary events. Make sure you've got those 3 things in your pocket. Those are your tools for doing probability. Okay, so let's read this carefully. Given the probability of A, the probability of B is equal to 0,4, and the probability of A and B is 0,3. Use the formula. This formula you can recognize immediately as our addition rule to determine the probability of A or B. Write your answer in decimal form. Okay, I am going to give you, without saying too much, I want to see what you guys come up with. I'm going to give you about a minute to try it on your own and just give it a go. Okay, so again, doesn't matter if it's wrong, Just give it a go. I just want to see what you guys do, okay? So, and hold your answers. I'll call for answers when the time comes, okay? But for a minute, work quietly on your own and try this one. Okay, if you've got an answer, pop it in the chat. Let's see. Got 0.6, we got 1/2. Remember, we want our answer as a decimal number. Okay, right, well, let's see. Watobians seem to be on it. 0.5 plus 0.4, that's the probability of A, plus the probability of B, minus the probability of A and B, so that is 0.3. That's going to be 0.9 minus 0.3 is 0.6. Yay, well done, guys. Well done. So you just substitute in. And you're just going to play around with the rule depending on what's given. So you treat those, the probability of A or B and the probability, all of those variables in the rule, you just treat them like variables and you substitute in what you have. Okay, let's go on to the next one. A and B are mutually exclusive events. Yes, Futali. Everyone else can read so long while I answer Futali's question. Yeah, Futali, you can answer. Hi there.
Hi, ma'am. Ma'am, can I ask, where did you get the 0.3?
The 0.3 is the probability of A and B. It's given in the question.
Oh, okay, thank you, ma'am. I will check it.
Okay. Right, so now we've got A and B are mutually exclusive, such that probability of A is equal to 0.6 and the probability of B equals 0.3. So determine probability of A and B and the probability of A or B. Okay, so let's do that first one first because I think that's pretty easy. Who's got an answer for us for the first one? What is the probability of A and B? Yes, that's 0, guys. 0 because it says that the two events are mutually exclusive. So probability of A and B equals 0. Okay. Now that we got that out the way, we can do the probability of A or B. So for mutually exclusive events, we can say that the probability of A or B is equal to the probability of A plus the probability of B. And some people are already on it. So for mutually exclusive, we can, and is 0, but or we can calculate. Yes, you have a question, Chinamiram.
Good evening, ma'am.
Hello.
Where is the P, A, and B? Because in the first question, 1A, there was P, A, and B in the formula, but here there's no P, A, and B.
Yes, there's no P, A, and B because P, A, and B is equal to 0 because these two events are mutually exclusive.
Oh, okay. Thank you, ma'am.
Okay, so for mutually exclusive events to do or, we just add the probabilities together. That's basically what it comes down to. And for mutually exclusive event, and is 0 because Just think back to your Venn diagram. There's no intersection. So it cannot happen. It's 0. Right. Let's go to the next one. Let's read. So if the probability of A is 0,5, the probability of B is 0,7, and the probability of A and B is 0,3, determine these 3 probabilities. Okay. I'm going to give you a minute to do this first one. Remember, there's no information here about them being mutually exclusive. So when we see probability of A or B, we can use our addition rule straight away. Yes, there is. So these events are not mutually exclusive. So we can just use our addition rule for it, Shiraz. Guys, we can't have probabilities greater than 1. So if your answer is greater than 1, check again. And we can't just divide by 100 to fix it either. Why are we getting answers greater than 1? Oh, sorry. I think there's a mistake here in the rule at the top of the page. Sorry, that was my mistake. The rule is with a minus, eh? So if you wrote it down with a plus, just fix it. It's with a minus. It's my mistake. See, we all make mistakes. So normal. Okay, so let's calculate the probability of A or B. So we get 0,5 plus 0,7 minus 0,3. Okay, so in the rule, that should be minus PA and B. So fix it if you wrote it down incorrectly, or take another screenshot of the correct rule. I thought I had fixed it, but I obviously didn't. And that gives us 0,9. Okay, so we all should get 0,9. If we are getting a number bigger than 1, there's a mistake. Okay, and what now is the probability of not A? Let's see who's been listening. Question 2, what is the probability of not A? Guys, think again. If you're saying 0,7, think about what you're saying. You're saying that the probability of A and the probability of B together, you can't have more than 1. Okay, so the probability of A is 0,5. So the probability of not A, this must add up to 1. So that is 0,5. Yeah. Okay, try again with the probability of not B. If the probability of B is 0,7, then the probability of not B. Yeah, that's right. It's 0,3. Sandukazi does a 0,3 question mark. Okay. Right, next one. Let's see. That's okay. Let's do question 4. I'm going to give you a minute. to do this one. So it says that A and B are mutually exclusive events such that probability of A is 0.25 and probability of not B is 0.58. Okay. Determine the probability of A or B. So my clue is to start off and find the probability of B first. Using your rules. Just hold answers for a second, everyone. Let's just give everyone a chance to think quickly. Okay, first pop in the chat. What is the probability of B? 0.4. I agree with that. Because not B is 0.58. So together they need to add up to 1. So probability of B is 0.42. Don't round at this stage. So if you're saying 0.4, you're rounding too soon. And by the way, as well, we don't really round probabilities. You must give the full answer. So it's 0.42. Okay. So the probability of A or B, and remember these events are mutually exclusive. So we're going to take the probability of A plus the probability of B. And we're not bothering with the minus P, A, and B because they are mutually exclusive. So that's 0.25 plus 0.58. Yeah, 0.42 is not correct. It should be 0.4 is not correct. It should be 0.42. That is the correct probability for B. I'm not sure everyone's getting 0.67. Oh, I know, because I got the wrong one. Cocky, you're just sitting quietly there.
I was getting to it. I was testing you.
Just wanted me to maybe do it. Okay, 0.67. Sorry, guys. Right, we've got some questions. Let's hear from Asanda.
Hi, ma'am.
Hi there.
Can I ask, how do we get 0.42?
Okay, so if the probability of not B is 0.58, then the probability of B plus the probability of not B must add up to 1. So the probability of B we got, that's 0.42. And then we're just going to subtract from the 1 the 0.42. So then the probability of not B is, oh, I got this the wrong way around. I'm winning here. Sorry, Asanda, let me do that again. So the probability of not B is 0.58. So to get the probability of B, we are going to just subtract from the 1, the 0.58. So that gives me 1 minus 0.58, and that is 0.42.
Okay,
there we go. So a few people asked that in the chat as well. There's the explanation. Chinemirum, ask your question.
Oh, no, ma'am, I wanted to ask about the P and B because I saw you wrote 0.58 and it was for P, not B. But then you changed it.
Yeah, I did.
That's what I wanted to ask.
Yeah, so the probability of not B is 0.58. And the not B and the B added together must give you 1. So we just subtract from 1 the 0.58 to get 0.42. Okay. Right.